Welcome to Wicked Shizuku's Reviews, bringing you a southern perspective on books, movies, music, and much, much more. Stick around for a while, you just might hear something wicked. And hello again, and welcome to Wicked Shizuku's Reviews Reads. And this is a Wednesday read, as it is episode 57. And I will be continuing today, in this episode, with H.G. Wells' The Outline of History, Volume 1. And we left off last time in, let's see, The Record of Rocks. This time, we will be picking up with Life and Climate. Oh, and by the way, if you're new here, welcome. And if you wish to listen to this from the very beginning, please go back into the playlist and you shall find this first episode on episode 3. So, I shall continue. Life and Climate. 1. Life and water. Water plants. 2. The earliest land animals. 3. Why life must change continually. 1. Wherever the shoreline ran, there was life, and that life went on, in and by and with water as its home, its medium, and its fundamental necessity. The first jelly-like beginnings of life must have perished whenever they got out of the water, as jellyfish dry up and perish on our beaches today. Drying up was the fatal thing for life in those days, against which, at first, it had no protection. But in a world of rain pools and shallow seas and tides, any variation that enabled a living being to hold out and keep its moisture during hours of low tide or drought met with every encouragement in the circumstances of the time. There must have been a constant risk of stranding. And on the other hand, life had to keep rather near the shore and beaches in the shallows, because it had need of air, dissolved, of course, in the water, and light. No creature can breathe, no creature can digest its food without water. We talk of breathing air, but what all living things really do is to breathe oxygen, dissolved in water. The air we ourselves breathe must first be dissolved in the moisture in our lungs, and all our food must be liquefied before it can be assimilated. Water living creatures, which are always under water, wave the freely exposed gills by which they breathe in that water, and extract the air dissolved in it. But a creature that is to be exposed for any time out of the water must have its body and its breathing apparatus protected from drying up before the seaweeds could creep out of the early Paleozoic seas into the intertidal line of the beach. They had to develop a tougher outer skin to hold their moisture. Before the ancestor of the sea scorpion could survive being left by the tide, it had to develop its casing and armor. The trilobites probably developed their tough covering and rolled up into balls, far less as a protection against each other and any other enemies they may have possessed than as a precaution against drying. And when presently, as we ascend the Paleozoic rocks, the fish appear, first of all the backboned or vertebrate animal, it is evident that a number of them are already adapted, by the protection of their gills with gill covers, and by a sort of primitive lung swimming bladder, to face the same risk of temporary stranding. Now the weeds and plants that were adapting themselves to intertidal conditions were also bringing themselves into a region of brighter light, and light is very necessary and precious to all plants. Any development of structure that would stiffen them and hold them up to the light, so that instead of crumpling and flopping when the waters receded, they would stand up and outspread, was a great advantage. And so we find them developing fiber and support, and the beginning of woody fiber in them. The early plants were reproduced by soft spores or half-animal gametes that were released in water, were distributed by water, and could only germinate underwater. The early plants were tied, and mostly lowly plants today are tied by the conditions of their life cycle to water. But here again, there was a great advantage to be got by the development of some protection of the spores from drought that would enable the reproduction to occur without submergence. So soon as a species could do that, it could live and reproduce and spread above the high water mark, bathed in the light, and out of reach of the beating and distress of the waves. The main classificatory divisions of the larger plants mark stages in the release of plant life from the necessity of submergence by the development of the woody support and of method of reproduction that is more and more defiant of drying up. The lower plants are still the prisoner of attendance of water. The lower mosses must live in the stages of extreme wetness. I'm sorry, I completely skipped a line there. The lower mosses must live in damp, and even the development of the spore of the ferns demands, at certain stages, extreme wetness. The highest plants have carried freedom from water so far that they can live and reproduce if only there is some moisture in the soil below them. They have solved their problem of living out of water altogether. The essentials of that problem were worked out through the vast aeons of the Proterozoic age and the Paleozoic age by nature's method of experiment and trial. Then slowly, but in great abundance, a variety of new plants began to swarm away from the sea and over the lower lands, still keeping to swamp and lagoon and watercourse as they spread. There was not, perhaps, the same distinction between sea plants and freshwater plants that there is today. The sea was probably less salt than it is now. And there is a plant, or a plate, illustration, and it is captioned with, "Note its general resemblance, except size, to the microscopic summer ditchwater life of today." And this is life in the early Paleozoic. You see them right there at the bottom? Two. And after the plants came the animal life. There is no sort of land animal in the world, as there is no sort of land plant, whose structure is not primarily that of a water-inhabiting being, which has been adapted through the modification and differentiation of species to life out of the water. This adaptation is attained in various ways. In the case of the land scorpion, the gill plates of the primitive sea scorpion are sunken into the body so as to make the lung books secure from the rapid evaporation. The gills of crustaceans, such as crabs, which run about in the air, are protected by the gill cover extensions of the back shell or the carapace. The ancestors of the insects developed a system of air pouches and air tubes, the tracheal tubes, which carry the air all over the body before it is dissolved. In the case of vertebrated land animals, the gills of the ancestral fish were first supplemented and then replaced by a bag-like growth from the throat, the primitive long swimming bladder. To this day, there survive certain mudfish, which enable us to understand very clearly the method by which the vertebrate land animals worked their way out of the water. These creatures, the African lungfish, for example, are found in tropical regions in which there is a rainy full season and a dry season, during which the rivers become mere ditches of baked mud. During the rainy season, these fish swim about and breathe by gills like any other fish. As the waters of the river evaporate, they bury themselves in the mud. Their gills go out of action, and the creature keeps itself alive until the waters return by swallowing air, which passes into its swimming bladder. The Australian lungfish, when it is caught by the drying up of the river in stagnant pools, and the water has become deaerated and foul, rises to the surface and gulps air. A newt in a pond does exactly the same thing. These creatures still remain at the transition stage, the stage at which the ancestors of the higher vertebrate animals were released from their restriction to an underwater life. The amphibia, frogs, newts, tritons, etc., still show in their life history all the stages in the process of this liberation. They are still dependent on water for their reproduction. Their eggs must be laid in sunlit water, and there they must develop. The young tadpole has branching external gills that wave in the water. Then a gill cover grows back over them and forms a gill chamber. Then, as the creature's legs appear and its tail is absorbed, it begins to use its lungs, and its gills dwindle and vanish. The tadpole can live underwater continually. The adult frog can live all the rest of its days in the air, but it can be drowned if it is kept steadfastly below water. When we ascend the scale of existence to the level of the reptile, however, we find an egg, which is protected from evaporation by a tough egg case, and this egg produces young which breathe by lungs from the very moment of hatching. The reptile is on all fours, with the seeding plant in its freedom from the necessity to pass any stage of its life cycle in water, but it can be drowned if it is kept under water without intermission. The later Paleozoic rocks of the northern hemisphere give us the materials for a series of pictures of this slow spreading of life over the land. Geographically, it was an age of lagoons and shallow seas, very favorable to this invasion. It is possible that as yet There were no seas as deep as the present oceans. The new plants, now that they had acquired the power to live the new aerial life, developed with an extraordinary richness and variety. There were, as yet, no true flowering plants, no grasses, nor trees that shed their leaves in winter. The first flora consisted of great tree ferns, gigantic equisteums, cycad ferns, and kindred vegetation. Many of these plants took the form of huge stemmed trees, of which great multitudes of trunks survive, fossilized to this day. Some of these trees were over 100 feet high. They belonged to orders and classes now vanished from the world. They stood with their stems in the water, in which no doubt there was a thick tangle of soft mosses and green slime and fungoid growths that left few plain vestiges behind them. The abundant pulped up remains of these first swamp forests constitute the main coal measures of the world today. Amidst this luxuriant primitive vegetation crawled and glided and flew the first insects. They were rigid-winged, four-winged creatures, often very big, some of them having wings measuring a foot in length. There were numerous dragonflies. One found in the Belgian coal measures had a wingspan of 29 inches. There were also a great variety of flying cockroaches. Ew. Scorpions abounded, and a number of early spiders. The spinnerets of these spiders were absent or simple, so that they made no webs or very simple ones. Land snails appeared. So too did the first known step of our own ancestry upon land, the amphibia. As we ascend the higher levels of the Paleozoic record, we find the process of air adaptation has gone as far as the appearance of true reptiles amidst the abundant and various amphibia. The land life of the Upper Paleozoic age was the life of an evergreen swamp forest without flowers or birds or the noises of modern insects. If a man could be transported back to those verdurous lagoons, he would probably be terrified at the stillness. He would hear little but the ripple of water, the sound of wind in the leaves, or the crash of some falling tree. Everything would seem waiting and expectant. The trees and plants would look more like magnified mosses than any trees or plants he knew. There were no big land beasts at all. Wallowing amphibia and primitive reptiles were the very highest creatures that life had so far produced. None of them had yet attained to very great dimensions. Whatever land lay away from the water or high above the water was still altogether barren and lifeless, but steadfastly, generation by generation, life was creeping away from the shallow sea-water of its beginning. 3. The record of the rocks is like a great book that has been carelessly misused. All its pages are torn, worn, and defaced, and many are altogether missing. The outline of the story that we sketch here has been pieced together slowly and painfully in an investigation that is still incomplete and still in progress. The Carboniferous rocks, the coal measures, give us a vision of the first great expansion of life over the wet lowlands. Then come the torn pages of the Permian rocks, which count as the last of the Paleozoic, that preserve little of the land vestiges of their age. Only after a long interval of time does the history spread out generously again. The Permian rocks record an age of harshness and desolation in the world's history. They mark the phase of transition from the Paleozoic age of fish and amphibia to the Mesozoic age of reptiles. It must be borne in mind that the great changes of climate have always been in progress, sometimes stimulating and sometimes checking life. Every species of living thing is always adapting itself more and more closely to its conditions, which are always changing. There is no finality in adaptation. There is a continuing urgency towards change. We do, however, find certain creatures of lowly type which early adapted themselves to widespread simple conditions so completely that they have never been greatly modified or exterminated or replaced. For example, there is a little shellfish called the lingula, fitted to an obscure sedentary life in warm seas. This genus has endured without conspicuous change throughout the entire geological record. On the other hand, geologists show us collections of fossils in which one can trace modifications in only a few thousand years as climate, food, and enemies have changed. About these changes of climate that are always in progress on the Earth's surface, some explanations are necessary here. They are not periodic changes. They are slow fluctuations between heat and cold. The reader must not think that because the sun and earth were once incandescent, the climatic history of the world is a simple story of cooling down. The center of the earth is certainly very hot to this day, but we feel nothing of that internal heat at the surface. The internal heat, except for volcanoes and hot springs, has not been perceptible at the surface since first the rocks grew solid. Even in the Azoic or Archaeozoic age, there are traces in ice-worn rocks and the like of periods of intense cold. Such cold waves have always been going on everywhere, alternately with warmer conditions, and there have been periods of great wetness and periods of great dryness throughout the earth. They depend upon astronomical and terrestrial fluctuations of extreme complexity into which we will not enter here. And, in accordance, we find from the record of rocks that there have been long periods of expansion and multiplication when life flowed and abounded and varied, and harsh ages when there was a great weeding out and disappearance of species, genera, and classes, and the learning of the stern lessons by all that survived. It is probable that the warm spells have been long relatively to the cold ages. Our world today seems to be emerging with fluctuations from a prolonged phase of adversity and extreme conditions. 500,000 years ahead, it may be a winterless world with trees and vegetation, even in the polar circles. At present, we have no certainty in such a forecast. But as knowledge increases, it may be possible that our race will make its plans thousands of years ahead to meet the coming ages. And this also has another bookplate, a diagram of life in the later Paleozoic age. Life is creeping out of the water. An insect like a dragonfly is shown. There were amphibia like gigantic newts and salamanders, and even primitive reptiles in these swamps. And we have finished that section, and next time we shall be starting on the age of reptiles. So, if you enjoyed this episode, if you found it informative, if you learned something, I would really like, subscribe, and share. And if you have any questions about this, I plead you to put them down into the comment section below, and I'll get back to you as quickly as possible. Have a good evening. Good night, everyone.